Well, hi and welcome to my shop, and let's carry on with this radio. I'm really focused on the very front end of the radio now, up in this area. I've checked this antenna coil and arrangement. Seems to be okay. I've also tested the tube. Seems to be okay. When I inject a signal by simply touching the grid cap here, comes out of the speaker, so everything seems to be okay except for something going on right with this tube, the circuits around the tube, or the circuits that feed the signal to the tube. There's not much of any of that really. So I think what I'm left with now is considering the condition of some of these individual components in here and seeing if we can find something that that might be the cause of what appears to be very poor sensitivity at the front end of the radio. Now, so let's have a look at the schematic here. And what I would become suspicious about, we're looking at this part of the circuit here. I would get suspicious about this resistor here and this capacitor. And this is the cathode resistor, 500,000 ohms. It's a pretty big resistor here, and a fairly large capacitor across it. So I'd be a little concerned that this capacitor no longer has any capacitance. It says 0.1, but it's really a 0.0001 now. And that would cause the signal that we're interested in amplifying to be kind of, in a sense, wasted across this resistor, not appearing where it needs to be. Instead of appearing across the whole tube and being able to be picked off the plate and then delivered further on into the radio, it would be developing across this resistor and just wasted there. So this capacitor is quite a suspicion, and I think we'll just do these one at a time, because what I really am interested in finding out here is what's wrong with the radio while I fix it. That's why I don't go in and wholesale change all the capacitors. There's a couple reasons for me not doing that, although sometimes it comes down to that, no doubt about it. But I really do want to learn why the radio does or doesn't do what it does. And if you go in and do a wholesale change of parts and then suddenly the radio is working, and my experience is that doesn't happen very often, frankly, you would never know what it was. You would just know it was one of those things. Frankly, what's more likely to happen, at least if I go in there and change all those parts, is I'll introduce more faults into the radio. So I'm very hesitant to do that kind of stuff. It's not necessarily a panacea for solving problems with the radio, and it doesn't help you understand in detail what's going on, and that's what I'm interested in. Frankly, I'm almost less interested in having the radio fixed than I am in the process of fixing it. That's what I find fun. So let's find this part and see about changing it. And I don't think it's going to be hard to find at all. In fact, I think it's just a little bit obvious. So here's the 6A7 tube right here. So this is the pins here for it. And right away, leaping into view. Let me give you a better view of this. Just give me 1 second here. So, I turned up the brightness on my camera. Now it's a little too bright, isn't it? So leaping into view anyway is this capacitor resistor arrangement, which I think matches what's on the schematic. Now let's just verify that by identifying the pin that it's at. That's not the easiest thing to do in this kind of tube here. So this is one of those ones without the center key. It's a little older. And so those are the heater pins down there. I'm not bothering to point. 6A7. Okay, so 6A7. So pin, that would be, by my reckoning, pin 1, 2, 3. 1, 2, 3. So this capacitor is on pin 3. Pin 3, no, it's a screen. It's the screen, and you know there's 5 grids in this tube. It's two of the screen, 2 of the grids, the screen grid, and another one. And let's just see if that holds up on the schematic here. Nah. What's going on there? Man alive, you know, everything seems to be a puzzle with some pieces missing when you do this kind of work. So we'll take a look again at the schematic here. Okay. So what is going on here? We just saw a capacitor resistor combination that is quite certainly pin 1, 2, 3. Pin 3. And pin 3, I'm double checking everything now while I'm saying this. So I'm looking up 6A7 again and looking. Pin 3 is grid 3 and 5. Grid 3 and 5. 5 is the, so here. Right here. There's the 2 grids, 3 and 5, and they're tied together. They're brought over. Oh, there's a capacitor there. Ooh, goes over into this network area. Otherwise, it comes across. What's that say? 40 what? Okay, not sure what that is. This is 40 mil, 40K, so that's a 40K. 40K is an unusual number. 40K resistor. I don't see any capacitor right across it. Capacitor to ground. I'm going to run my eye all over the place. So what about this other capacitor? This one here, 0.1, over here, down here, down here. Now this looks kind of look a little more like a ground, doesn't it? Come along here, all this stuff's connected to it. Over here, up here. Here's a similar arrangement here of what I'm seeing in the radio, a resistor capacitor. Comes across. Oh my gosh, this is a really is it the chassis ground? I'm not sure. But when we look at the radio, if I've got this right, if this is the resistor we're looking at and this is the capacitor, which is not making sense, this capacitor in the radio goes right to ground, right off these pins. Maybe I'm counting something wrong because it's not making a lot of sense here. Let me show you on a close-up. Hang on tight here. Okay, so here's what we're talking about. We're talking about this tube right here. And these pins. And let me get a good pointer. This will do. So the 2 pins down here, this one and this one, those are the heater pins. I'm pretty sure of that because they look a little bigger, plus the arrangement. There's a certain pattern to how these 2 pins run. And there's only 2 that are kind of lined up, if I can put it that way. There they are. So I'm sure these are the heater. That makes that pin 1. That makes that pin 2. That makes that pin 3. Pin 3 is connected here. There's the capacitor and the resistor. I'll have to check the value of that resistor. And then look, way out here, flying in the air, is a connection to ground. What the heck is going on? Now here's a similar thing over here. There's the ground. There's a capacitor resistor combination, and it's going into a different tube, so that's another matter. But this doesn't seem to match the schematic. And that's a smallish looking capacitor. What is it? That's a 0.02. Can you see that? Come on, Mr. Focus. Man, I tell you. This is a great camera, but it just doesn't want to focus half the time here. Anyway, that does say 0.02. There, you can kind of see it now. 0.02. 0.02. So maybe I've got the tube numbering totally wrong on this tube. Let me, what? Just nothing is ever straightforward on these things, it seems. Nothing. And I'm suspicious about this part too, because it kind of looks like, well, there's no question, somebody's worked on it. Did they do something dumb and the radio never worked after that? Generally speaking, I know what I do when I do something dumb. I figure it out and undo it. I don't do something dumb and then leave it and walk away. So you got to imagine this radio was working just like this at one time, and the reason it's not working now is some kind of component failure, not a wiring error. Nevertheless, that's not making a lot of sense. Let's look at the schematic again and see if we can find where there's a 0.02 on here. Okay, so in 1 second. These cameras are so very, very light that even the weight of the cord will pull them around. So, okay. Oh, I get to use my nice, here, I'll use this nice red pointer. Okay, that's great. Okay. So this is the guy we're suspicious of. 0.1. Now where's a 0.02 coming off this tube? There's a 0.1, 0.1. There's a 0.01 down here. 0.000, too many zeros. 0.05. But that doesn't connect directly into the tube here. What is going on? Now, it's possible, you know, that if you put this big resistor, then you need that size capacitor. If you put a different size resistor, a different size capacitor will more or less work. Could the guy who worked on this thing been so smart as to just alter all the sizes? No, I don't think so. What is going on? Let me measure the size of the resistor there. Maybe that'll give us... That'll probably just give us more confusion, but... You know... We'll see if we can get the Phoenix effect going here, or, you know... Out of the ashes of my theories will come the truth. Let's see. Oh, so we think this is a 500,000. Okay, I can put it there. Well, we don't know what it is. Let's see. Oh. Well, that's pretty interesting, isn't it? Huh. I think we just found our answer here. No, let's see. Okay, so that's saying it's around 600 ohms here. I get a better reading because it's jumping around. 450 ohms. Okay, 450 ohms. Now, you know, that's not an unreasonable size for a resistor in the cathode circuit. But unless you know this 500M is really 500, and the M is really an ohm symbol. Let's see. Hey, Mr. Camera, can you focus, please? Well, I wouldn't put a 500,000 ohm resistor in the cathode. Wow, you know, that could be anything, couldn't it? 500 meh. So look at this one though. Look at this one. That's clearly 300 ohms. Okay, and look at this one. This one is clearly 5 M. Oh, this one is an ohm, 700 ohms. That one is 300 M. Oh, okay. Excuse me. I'm really enjoying this. Okay, so now what do we think that is? That is still, you can't tell. But I just don't think you would put a 500,000 ohm resistor in the cathode circuit of a tube unless it's a cathode follower and you're going to peel the signal off of that resistor. That's not what's happening here. Okay, so I'm thinking this just isn't adding up, because look where the resistor goes. I mean, on the radio it's going to ground, to the chassis. On this circuit, it's going to another capacitor. What is happening here? Oh man. I'm really stumped. I'm stumpified. Okay, first, I think we gotta absolutely convince ourselves that I'm looking at pin 3 on this tube, because now I'm totally unnerved on everything. Totally unnerved. So let's pull the tube out and look at it again and see. And just, you know, I just can't be certain enough on these things. Okay, so I pulled it out. Lordy B, I was totally wrong on the tube counting. Okay, totally wrong. So the two fat pins are here. Okay, that's going to help. They aren't where I thought they were, even though I convinced myself of it. It's good to go through life with a fair bit of self-doubt. Okay, so that means this top pin is pin number 1. That means that... What does that mean? I gotta get out my tube diagram again. 6A7. Okay, so I'm looking at the 6A7 here. It's right down here. It's this one at the bottom here. I doubt you can see it clear enough. Pin 2 is the plate. Oh, I'm counting totally backwards here. Hold on, I'm totally messed up. Hold on. So that would be 2, 3, 4, 5, 6. This is pin number, this one with the capacitor is pin number 6, in fact. 6 is the cathode. Wow. Okay, so 6 is the cathode. And so we are looking at a capacitor which is across a resistor, which is going straight to ground, not back into the antenna system. Because wow, I don't. This is. Let's see what's going on here. So here's a switch. That when it's closed, none of this matters here. It's all shorted out, and you're just picking up a signal from the antenna coil here into this coil, tuned and delivered by my reckoning here, delivered into this grid number, that would be grid number 4. And then if the switch is open, there's a band switch. If it's open, now you've got all these coils working together. This is still tuned, but the tuning won't have much effect. This one is tuned to the frequencies of interest, so this coil will start providing a signal. And the signal is once again fed back right into the same grid, same sort of thing. Now, this point here, which happens to go to the grid of the magic eye, it's protected by a capacitor, so only signals can get through here, no DC. No DC. Wow, this isn't... So that must be a connection point right there, where those wires are crossing, because they show the jump when the wires don't connect. So I have to assume that's a connection, even though they haven't bothered putting a dot there. There's no dots on this diagram anywhere. So that's a connection point. And that point is coming from this ground. Oh, so that is ground. Ah, so this is taken to ground. And you know, it is normal for a cathode resistor to go to ground. That's quite common with a bypass. Okay, so now we've proven that the capacitor resistor combination is appropriate where it is. It should go to ground. It should be 500 something, probably 500 ohms, with a big fat capacitor. Of course, this wouldn't be big and fat. I'm just commenting on the relative capacity of it. But instead, here we have a 0.02. We have a resistor that measures, what was it, 300 and something? If you don't put a big enough capacitor here, or if the capacitor you have here has lost its capacity, then it can no longer bypass this resistor. The signal will not bypass the resistor. And it will, again, like I said before, it'll be consumed in here. So, you know, it's all about this capacitor not having any capacity. At 0.02, right from the start, it's too small. We can easily bridge this with a 0.1 temporarily and see if the radio comes to life. That sounds like an interesting experiment. Why don't we do that? After I've talked to myself, how long have I been running this video now, and I have done nothing but yap. But that's what happens when you're doing radio repair. A large portion of it is pondering, thinking, and doing this kind of thing. It isn't always about cutting out parts and soldering in new ones. Especially if you're taking my approach, the troubleshooting approach. There's a lot of thinking and poking and testing without actually... I don't even have my soldering iron turned on yet. Now it's hard. So that's what we're going to do. I think I'll stop this video here. In the next video, we'll actually do something with that capacitor.